Okay, let's start talking about reflection in a little more depth. So, like we just mentioned, a reflected sound wave is called an echo. But we're mostly going to be dealing with reflection when we talk about light. So, when we're talking about light, the thing you think of is a mirror. Incident ray comes in, incident ray comes off. Remember, a ray is just a way to represent the direction that a wave is traveling. So, wave goes that way, ray is the center line of that wave. And the thing that's neat about reflection is that your angle of incidence, the angle the ray comes in, is always going to be equal to the ray comes back out, the reflected ray. And we represent those angles as measuring from the normal to the angle where they come in. Remember, the normal is just perpendicular to the surface. So the angle of incidence is always equal to the angle of reflection. So let's see how this works when we do an actual diagram. Here's a mirror in the middle, and here's my object. Let's say I have one light ray that comes off and hits this. Well, it's going to be reflected straight back. So here's my reflected ray straight back. That's a real ray. Now over here, our brain interprets the ray as coming from over there. So what I'm going to do is I'm going to draw a dotted line back. Now, light comes off of this object in every direction. We only need two rays because where two rays come together, it makes a point that shows us where the object is. So I'll just pick an angle right here. Let's just say this light ray goes like that. Now, here's my normal line right there. This angle has to be equal to the angle that it comes off on. Here's my reflected, here's my incident. Now, my brain, when it sees that light, is going to trace it, because your brain does not understand how reflection works. Your brain just sees light comes straight, must always go straight. So it traces back in its head right over there, and wouldn't you know it? This distance, same thing. What we see in the mirror over here is called an image. And for flat plate mirrors, your image is always going to look just like your object. So I want you guys to take a second, and I want you to tell me whether this is an upright image or inverted. I want you to tell me whether it is larger, same size, or smaller. And then I want you to tell me whether this is a real or a virtual image. Real meaning that you could project it onto a surface and you'd be able to see it. Virtual mean you can only see it with a brain and some eyes. So go ahead, think about it, take a second, circle the one you think is right. Cool beans. Well, obviously it's upright because the top is at the top. So nice. And you should know that. If you've ever looked in a mirror, you don't appear upside down. You're flipped, but you're not upside down. The next thing we see is, look at this, same distance from the floor. It's going to be the same size. That's the neat thing about mirrors. That's why they're so useful. Flat mirrors show you exactly what you look like, just reversed. And then finally, this is going to be a virtual image. We'll see later when we start getting into curved mirrors that you can actually project images onto stuff. When we get into lenses, you'll be able to project an image of something onto a flat piece of paper. But with a mirror, I can't reflect my image. All I can do is reflect bright light. So in this case, it's going to be a virtual image.